Let's look at a dice. Imagine we roll this. We can get a whole lot of different answers. We can look at, there's all sorts of different possible answers we could get, right? 1, 2, 3, 4, 5, 6. Every time we roll it, well, almost every time we roll it, it comes up with a different answer. It's a really nice example for a standard discrete uniform distribution. We know that the probability of getting every number is the same, that it doesn't matter, there's no cluster in the middle or anything, it's the same. And so the probability of getting a 5 is 1/6, the probability of getting a 4 or a 5 is 2/6, the probability of getting a 1, 2 or 3 is 3/6, and so on. It's a lovely little device for working out a uniform distribution. Now, but what if I asked, what is the average, what's the mean dice roll? If you rolled the dice a number of times, what's the mean you'd get out for rolling them? So we're going to have a look at that and how we're going to find that and how we find it for other for other uniform situations, including ones that are continuous, not just discrete. Let's have a look at it. Okay, we know that there's an equal probability for getting each one of the numbers, 1, 2, 3, 4, 5, 6. So we could say if we had 6 dice roll, we could assume that it would average out that you'd get 1 of each number. So let's imagine we did that. We rolled 6 of them, we had 1 of each. If we were to add them up, our total would be 1, 2, 3, 4, 5, 6, which is 21. Right, so we have 21 as the outcome from having rolled the dice 6 times. So our mean is going to be 21 over 6. 21 over 6, which is going to cancel, which is going to come down to 7 over 2, or 3.5. Right, now we're going to have a look at this. Where did the 7 over 2 come from? Well, if you look at it, we've got 1 and 6 add to 7, 2 and 5 add to 7, and 3 and 4 add to 7. And so the average is just going to be those two and half of it, because we can pair them all up. Now, because it's uniform, that's actually going to always end up working. I'll show you another example. Let's imagine we had another uniform distributed random number. All right, this one here, discrete again, but this one here, instead of starting at 1 and going to 6, there's only 5 options, and it starts at 7, 8, 9, 10, 11. Now we can't skip any because it's uniform, so it needs to be the same the whole way across. Right? So again, if we look at this, when we find the mean of this, because we'd assumed we had 1 of each, well, watch this, it's going to be 7 plus 11, which is 18, 8 plus 10, and 9. So we can halve all of that, which is going to get us 9. Right. And again, we can see the first number and the last number, we add them together and we halve it. So this time 7 plus 11 is 18, divided by 2 is 9. Just like with the last one, we add them together and we halved it. We did 1 and 6, it becomes 7. And it turns out that that works for all uniform distributions, whether it's continuous or discrete. You can still find the mean by just adding up the first number and the last number and dividing by 2. Which is quite useful because it means that if we know that something is a uniform distributed random number, or if there's follows a uniform distribution or a rectangular distribution, that we can find the mean from it really easily. It turns out we can actually also find the standard deviation really easily. I'm not going to show you the proof for the standard deviation. I'm just going to go through and explain it and give it to you. But there is a proof for it on the back of the textbook. but it's again a really simple thing to find the standard deviation, the standard deviation for a rectangular distribution. Here's, if we have our standard density graph where we have A and B on it, the mean, as you'd sort of expect if you think about it, is going to be bang smack in the middle of that. A plus B minus divided by 2. So we put our mean in here. So I mean, now the standard deviation, there's a formula for that. So that's the mean. And the formula for the standard deviation is B minus A over the square root of 12. So if we think about it with our dice that we had before, it's going to be B, which is the large number, 6, minus A, 1, which is 5, over the square root of 12. If we look at the one that we had with the 5 parts of it, it's going to be 11 minus 7, which is 4, over the square root of 12. And that's pretty much what there is, all there is to it. It's just a case of doing that. You will find the the standard deviation and the mean. Okay, so here's an example of a problem that could use this. The Austrian train system is famous for running precisely to time. The trains often pull away from the station exactly on the second that they are timetabled. Now, Van Ost is one of the busiest stations. It's quite a beautiful train station, and the train leaves there once every 3 minutes. The time that people arrive at the train station, though, isn't quite as precise. It's actually uniform distribution. People are just as likely to arrive 3 minutes before or 2 minutes after. Or the time that they arrive is not related to the time that the trains go, because it's so reliable that they can just turn up. They know there's going to be one going within 3 minutes. So we want to know what the mean wait time and the standard deviation for the wait time is. So if we think someone could arrive 3 minutes before, 2 minutes before, 1 minute before, or bang on time. And so we assume that all of those will get on. So someone either has to wait 0 or the most they can wait is 3 minutes. So if we were to draw ourselves a little graph, we've got 3 minutes and 0 minutes. That's our A and B. Now we can work this out. We can say, well, we've got a length of 3 across here, and we want to have the area of 1, so that's going to have to be 1/3. Although it's a little bit meaningless as to the height of it, unless we're working out the areas. But we don't really need to do that because we can just find the proportion to find probability. But here we wanted to find the mean. So the formula for the mean is A plus B divided by 2. 0 plus 3 divided by 2. So the mean wait time forgive my bad handwriting on the tablet, it's not very easy. And that equals 3 plus 0 over 2, which equals 3 over 2. The standard deviation is also going to be using the same formula. This time we'll just have the standard deviation is going to be 3 minus 0 over the square root of 12. Right, and we can bang that into the calculator. We go 3 divided by the square root of 12, and that equals 0.866. So we can find the mean and the standard deviation just by using a fairly simple formula and working our way through that.